Look up at the night sky. Take a moment to let your eyes adjust to the darkness, and you'll begin to see a tapestry of stars twinkling above you. On a clear night, far from the intrusive glow of city lights, a faint band of light graces the heavens. This ethereal glow is a breathtaking sight, a reminder of the vastness of the universe. We call this celestial river the Milky Way. It's a name that evokes both mystery and wonder, a fitting title for such a magnificent feature of our night sky. This river of stars has captivated humanity for millennia. Ancient civilizations wove tales and myths around it, seeing it as a bridge to the divine or a path for souls. The Milky Way is not just a band of light, it's a vast collection of stars, gas, and dust. It's our galactic home, a sprawling city of stars where our solar system resides. The reason the Milky Way appears as a band is because we're inside it. From our vantage point on Earth, we are looking edge-on at the dense plane of our galaxy. Imagine yourself embedded within a pancake. If you were inside it, you would see batter stretching all around you, creating a flat, circular view. Similarly, when we look at the Milky Way, we see stars stretching all around us, forming a luminous band across the sky. That's what we see when we look at the Milky Way. We are peering through the dense disk of our own galaxy, a perspective that offers a unique and awe-inspiring view. We're looking through the disk of our own galaxy, a vast rotating collection of stars, planets, and cosmic dust. The Milky Way is a barred spiral galaxy, a majestic structure with a central bar-shaped region of stars and spiral arms that wind outward. It's about 100,000 light-years across, an almost incomprehensible distance that underscores the enormity of our galactic home. Our solar system lies within one of its spiral arms, specifically the Orion Arm, a relatively small and quiet neighborhood in the grand scheme of the galaxy. We are but one small part of this enormous structure. Our sun is just one of billions of stars that make up the Milky Way, yet, from our vantage point, we can observe its wonders and unravel its mysteries. Through telescopes and space missions, we continue to explore and understand this vast cosmic river, revealing the secrets of our galactic home. From ancient astronomers who first charted the stars to modern scientists using advanced telescopes and space missions, our quest to understand the Milky Way has been a journey of discovery and awe. So next time you find yourself under a clear night sky, take a moment to look up. Let the sight of the Milky Way remind you of the incredible universe we are a part of, and the endless possibilities that lie within it. The Milky Way has distinct parts. Each part plays a crucial role in the structure and function of our galaxy. From the central bulge to the spiral arms and the vast halo, every component is interconnected in a grand cosmic design. At its center lies a supermassive black hole. This black hole, known as Sagittarius A*, is a gravitational powerhouse that influences the orbits of stars and other celestial bodies in its vicinity. This behemoth is millions of times the mass of our Sun. Its immense gravity pulls in matter and light, creating a region of space where nothing can escape. Surrounding the black hole is a central bulge. This bulge is a densely packed region filled with older stars, gas, and dust. It's a dense region packed with stars. The stars here are much older and have different characteristics compared to those in the spiral arms. Extending outward from the bulge are the spiral arms. These arms are not just beautiful structures, they are dynamic regions where new stars are constantly being formed. These arms are where stars are born. The process of star formation is fueled by the abundant gas and dust found in these regions. They contain vast clouds of gas and dust. These clouds, known as nebulae, are the birthplaces of stars and planets. Our solar system resides in one such arm called the Orion Arm. This arm is a minor spiral arm, but it is home to our Sun and the planets that orbit it. Finally, there's the halo. It's a vast spherical region that surrounds the entire galaxy. The halo extends far beyond the main visible components of the Milky Way. The halo is home to globular clusters. These clusters are tightly bound groups of stars that orbit the galactic center. These are ancient groups of stars that orbit the galactic center. They are some of the oldest objects in the galaxy, providing a glimpse into the early history of the Milky Way. Together, these components create the grand design of our galaxy, a cosmic masterpiece that continues to fascinate and inspire. Stars are the building blocks of galaxies. They come in different sizes, colors, and temperatures. Our Sun is a yellow dwarf star. It's about halfway through its lifespan. Massive stars burn bright and die young. They explode as supernovae. These explosions are some of the most energetic events in the universe. They scatter heavy elements into space. Smaller stars like red dwarfs live much longer. They can burn for trillions of years. These stars are far more common than massive ones. Our solar system is not unique. Astronomers have discovered thousands of planets orbiting other stars. We call them exoplanets. These discoveries have revolutionized our understanding of planetary systems. Some exoplanets are gas giants like Jupiter. Others are rocky worlds like Earth. The search for life beyond Earth focuses on planets in the habitable zone. This is the region around a star where temperatures allow liquid water to exist. The discovery of exoplanets has profound implications. It suggests that our galaxy may be teeming with life. Section 5. Eyes on the cosmos. We use incredible tools to study the Milky Way. Telescopes on Earth and in space provide stunning images. They reveal the galaxy's structure and composition. The Hubble Space Telescope has revolutionized astronomy. It has captured breathtaking images of distant galaxies. It has also helped us study the Milky Way in unprecedented detail. New telescopes are constantly being built. They will be even more powerful than their predecessors. They will allow us to peer deeper into the cosmos than ever before. Section 6. Our place in the galaxy. Our solar system is located about 26,000 light-years from the galactic center. We orbit the Milky Way at an astonishing speed. It takes us about 230 million years to complete one orbit. Our position in the Milky Way is not fixed. We are constantly moving through the galaxy. Our solar system is just a tiny speck in this vast cosmic dance. Yet, from our humble vantage point, we are able to study the universe around us. Section 7. The Milky Way's future. The Milky Way is not static. It is constantly evolving. Stars are born and die. Gas clouds collide and collapse. Black holes lurk in the shadows. In about 4 billion years, the Milky Way will collide with our nearest neighbor, the Andromeda Galaxy. This collision will be a spectacular event. It will reshape both galaxies. But fear not. Galactic collisions are slow and drawn-out affairs. The stars within the galaxies are so far apart that individual collisions are unlikely. Section 8. Dance of the Galaxies. In this chapter we will explore the intricate and mesmerizing dance of galaxies in the vast expanse of the universe. The Milky Way and Andromeda are part of a larger structure called the Local Group. These two massive galaxies are the dominant members of this group, which is a small part of the universe's grand tapestry. This group contains about 50 galaxies. Each of these galaxies, with their billions of stars, planets, and other celestial bodies, contribute to the Local Group's dynamic and ever-changing nature. They are all bound together by gravity. This invisible force acts like a cosmic glue, holding these galaxies in a delicate balance, influencing their movements and interactions. The Local Group itself is part of an even larger structure called the Laniakea Supercluster. This supercluster is a vast collection of galaxies, stretching across unimaginable distances. This supercluster contains hundreds of thousands of galaxies. Each galaxy within Laniakea is a bustling metropolis of stars, planets, and cosmic phenomena, all interacting in a complex web of gravitational forces. It spans hundreds of millions of light-years. To put this into perspective, a light-year is the distance light travels in 1 year, about 5.88 trillion miles. The scale of Laniakea is truly mind-boggling. The universe is filled with such structures. These superclusters form a vast cosmic web, with filaments of galaxies stretching across the universe, connecting clusters and superclusters in a grand cosmic dance. They are a testament to the power of gravity. This fundamental force shapes the universe, guiding the formation and evolution of galaxies, and creating the intricate patterns we observe in the cosmos. They show us that the universe is interconnected on a grand scale. From the smallest galaxies to the largest superclusters, everything is linked in a vast, dynamic network, illustrating the beauty and complexity of the cosmos. Section 9. Our Cosmic Legacy. We are just beginning to explore the Milky Way. We have much more to learn about its history, its structure, and its future. Every new discovery fills us with awe and wonder. It reminds us of the vastness of the cosmos and our place within it. Our exploration of the Milky Way is a journey of discovery. It is a journey that will continue for generations to come. Section 10. A universe to explore. The Milky Way is just one galaxy in a universe filled with billions of others. Each galaxy is a vast island universe. Each one is filled with its own wonders and mysteries. The universe is a vast and awe-inspiring place. It is a place of endless possibilities. It is a place that we are only beginning to understand. Let us continue to explore. Let us continue to learn. Let us continue to be amazed by the universe and all that it holds.